And then, any questions so long while we're waiting for these guys? Anything from your side that you might want me to handle so long?
I was looking at the algebra fractions,
Okay,
the plus and the minus ones, today.
okay, okay.
Um, it's not really a big problem, but
Yes.
if you can maybe do one, I just wanna go through the plus and minus. I did the multiplication and the divisions, and it's fine.
Okay, okay, okay.
But in this book I'm using, then there was this plus and minus thing, and
Okay,
uh, it's not really difficult. It's like the factorization,
okay, okay. Do you
but
maybe have one I can try it out here because it's similar to this? Anything that you can see
um,
from your side? Yeah, you can
let's
go check your book and then, yeah, we still have a bit of time.
see.
Yeah, just,
Um, let me just choose a random one here.
yeah,
So in my book here, I have okay. So it's a x plus 2/5.
X, let me write it down. You are saying it's
Okay.
X
Plus
plus
2.
2
Uh-huh.
over
Uh-huh.
5,
Yeah. Minus
minus
x plus 3
X plus
plus
3.
over 2.
Okay,
That's it.
all
That's
right.
the thing.
Okay, so the aim here is to, this is a minus, right? So
Yeah.
I'm gonna approach it in two ways.
Okay.
You're gonna choose how you might want to approach it. So
Mm-hmm.
one way is this version to say you take this 2,
Uh-huh.
it goes and multiply everything here.
Okay.
It will multiply. You take this 5, it goes and multiply everything here,
Okay.
and then you multiply this 5 and this 2.
Like you said yesterday. So
Yeah.
so you can cross multiply them. Is it?
Yeah, it's like cross, yes, you cross multiply. So what you'll be
Uh-huh.
having, you'll be kind of saying 2 bracket, don't forget the bracket, x plus 2, and then you say minus, and then you've got 5 bracket x plus 3. Are you seeing this?
Okay.
Then you
Yeah.
divide by 5 times 2. That is one
Oh.
way. We'll compare our answers, and then from here you have to open this, open this bracket. And
Yeah.
then don't forget this minus 5, not just 5. And
Uh-huh.
this minus 5 doing that. So that you've got 2 times x, it becomes 2x. 2 times 2, it becomes positive 4. Now it's minus 5 times x, minus 5x. And minus 5 times 3 is minus 15 over 10. You see? And then from here, you collect like terms. 2x minus 5x. These guys, they are common here. You see? So
Yeah.
2x minus 5x, then it gives me minus 3x.
Yeah.
And then the other one is to say 4 and 15 there. To say 4 minus 15, I think it will give me 11. Negative 11.
Yeah.
Yeah. So here I'll have negative 11 and then divided by 10. So this will be the solution. Can't go further.
Okay.
So that is one way. The second way is to do this. The second way is to do this. Now let me write again. X plus 2 over 5 minus x plus 3 over 2. The second one is to say what is my highest common factor, so my highest common factor between 5 and 2 is 10. You see the number that can go into 2 and 5, the number is what? Is 10, the
10.
factor of 5 and 2. Then from there you are saying 5 into 10, it's 2, and then multiplied by the top, which is x plus 2. Right? Minus, how many times does 2 go into 10? It goes 5 times, bracket x plus 3. You see? Then we are here.
So it's actually easy, man.
Yes, then it becomes the other one there. So then sometimes though they will give you this. Let me just add a little bit there, a little bit of twist. They can do this to you to say x plus 2 over 5 minus x plus 3 over 2. Then they say plus 3. You see that now? They just added an extra number there. Then this one now, you have to focus on this method now here, this one.
Okay.
Whereby you have to find the lowest common multiple between these 5, 2, and 1. So it will maintain being 10 there. That's the one. Where you say 5 into 10, it's 2, bracket, x plus 2. Similarly, minus 2 into 10, it's 5, bracket, x plus 3. And then you continue further to say 1 into 10, it's plus 10, bracket 3. See? That's the whole thing. So it's 1 there. So you get everything, but the only difference there, you say plus, then it will be 2x here, plus 4 minus 5x minus 50. Now you have got plus 30 now. See? Then over 10. Then the numbers now you have is these numbers that you add. So 2x minus 5 is minus 3x. And then 4 minus 15. Okay, actually 15 minus 30 is positive 15 there. Plus 4 is 19 over 10 there. That's what you'll be having.
And that will be your answer.
That will be your answer, yeah. As long as you can factorize it further. 19 doesn't have factors. And always, as I said, try test it where you choose any value of x. For example, here maybe say x is equal to 4. So what you do is, it helps to you to kind of give you an assurance, to say, let me just use my calculator here, to say, am I doing it right? So here I will say that, and then it's minus 3 times, I said my x is 4, where there is minus 3x plus 19, then I divide by 10, right? I get my answer is 7 over 10. Then I take the original one, because I got 7 over 10 in the bottom. Let me go to the original one. We said x plus 2, which is 4. I said my x is 4 plus 2 over 5, right? And then minus, and then I say 4 plus 3, x plus 3 over 2, and then I say plus 3. It must give me that is, was it 2 over 7 over 10? Yeah. So when my answers are matching like this, then I know, look, I'm in the right.
You know.
Yes.
Yeah.
So that is the kind of thing. You wanted to ask something a bit there? I think.
No, it's fine, because I was, the book says you have to factorize, so, and sometimes it takes long to factorize.
Yeah. I understand.
The right factorization.
Okay. So
that makes sense.
Yeah.
It helps.
Okay, so yeah, it's a matter of, as you say, some they need factorization, but the most simple part is to ignore other things and just do the normal procedure straight away.
Okay.
Yeah.
Okay.
So that was that, man. I think we were working on. Let me just take you back a little bit here. We're here. See, I don't see anyone joining, but we did these fractions. We did that LCM, HCF, and then we did exponents and logs.
That's it.
Yeah, if ever you find yourself having some questions, especially on logs, please bring them on for me before the end of this week when we are wrapping up. Find yourself doing logs and exponents. Trust me, it can shake you off, especially logarithms. So get time to go through a bit of logs in your previous whatever thing. Bring in your questions maybe on day 5, just to kind of lay. I know I just did it so quick and we're already exhausted by the time we're doing this, but especially on log. All right. So now today we are looking at 5, which is equations, subject of formula, distance, speed and time, revolutions, and word problems. Right. Now I think mostly I didn't do that part. I'll look for that question, but I have subject of formula, equations, distance, speed and time, and word problems I have. Then we will also look at this one, algebraic graphs and graph sketching. All right. Okay. So let's just brace yourself, my man. I know you are tired, but who cares, my man? Who cares? No one cares, All right. So no one is joining. I think I have to hit the on with the class. Look at this one. Now, 5 equations, subject of formula. Are you able to see my screen?
I can.
All right. Now it says change the subject of formula. Here, it's one area that is not difficult in the sense that, to me, this is the foundation of normal algebra. When they say change the subject, it's algebra, because it helps you to know which one goes where, when do you change the sign, when do you divide, all those things.
Yeah.
So here they are saying we must make P the subject of the formula. So if you can look at this, if I can make this guy bigger here, you can see that P is there, but unfortunately P has a what? Has a power of 2 squared. So what must I do first? Again, P has a negative. It's a problem for me. I'm looking for P. There's a negative, which it must be positive. It has a squared. So the best thing to do is to get rid of the negative first. Two ways I can do. To get rid of a negative, I can take P to jump this side. That's a simple way of getting rid of a negative. But since my interest is P, I can then also take Q to join this side. So I will have Mn. Now Q was positive, it becomes minus Q is equal to P squared. Alright, I'll show you the way when I leave the negative what it's going to do, but this is the better way I'll advise. Then I can rearrange, like take this to say this means P squared, I'm starting with P now, is equal to Mn minus Q. Right, now how do I get rid of the square? I square root. But what you do on the left, you do on the right. And don't forget, you must say plus or minus. Don't forget. Whenever you square root, you say plus or minus. Right? And then after that, you've got P is equal to plus or minus square root of Mn minus Q. That was one way. The second way, you would have argued and say, what if I want to leave P on the other side? I would have had Mn minus P squared is equal to Q. So what I can do, I can take Mn to the other side. So I have minus P squared is equal to Q minus Mn. It was positive, became negative. Now, you see, remember, I cannot square root now because of this negative. I can't do this because there is no square root of a negative. First, I must deal with that negative. How do I do it? I divide by minus 1. And then even here, I divide by minus 1. So that this goes a negative and a negative. Then from there, I'll have P squared. Now, when you divide something by minus 1, you interchange the signs. Q becomes minus Q, minus Mn becomes plus Mn.
Okay.
You understand? Then, when that is gone, I can then go on and square root, and then plus or minus. You see? Then I will have now P is equal to, if I'm to start with positive Mn, it will be Mn minus Q. You see, taking us back there. So
I like the first option better. It's easier, I think.
The first one.
Yeah.
Just whatever you want has got a negative on it, it's easier to make it cross, get rid of that negative without divisions, So that is that part. Now look at the other one here on the next one here, I think, yes, this one. They want to make A the subject there. You see this one? Now you look at it also carefully here. A is there, and what do? Already it's positive. Why don't you take ut to the other side? So you've got S minus ut, you see that, is equal to 1 over 2 at squared, you see. Now, two things that are now affecting your A. It is half and t squared. It's so simple, man. Just divide by 1 over 2. You don't want that. And t squared. You don't want that then. That's all. Don't say I must get rid of whatever. Just do this. Cancel that. And then cancel that. So after that, but I'll show you the what would have been the right procedure though, but this is fine still. So what you do on the left, you do on the right. 1 over 2 t squared, right? So then A is left. There is A. S minus ut over half t squared. You can argue. I think if you write like this, they won't penalize you. It's difficult for me to penalize you this. Though the right procedure would have been, I'll show you the right procedure from here, the right procedure would have been when I give you and say S minus ut is equal to 1 over 2 at squared. The right procedure is get rid of that half. So what you do, you multiply by 2 on the left bracket, you multiply by 2 on the right. That's how this can go away.
Okay.
You see. Then that 2, you don't have to open, it will be s minus ut there, right, is equal to a t squared. See, then you divide by t squared, you divide by t squared. Are you with me? Then you have got your a is equal to 2 here, and then s minus ut bracket over t squared, right? If you knew, look at this where the 2 is. Usually this, if I can bring it here on my final answer, you can actually write that this 2 can still go up there and you put brackets, you know, because if I give you this, if I say 1 over 2, this is 2, this 2, because there are 2 division lines, 1 and 2, this 2 goes to the top, you know. So you can just test that, just giving you a calculator. If I say fraction 1 over, then I put a fraction and say 1 over 2, then the answer becomes this, that is on top there. So here you would have seen that, okay, there is a fraction and then there is a fraction, actually this thing is on top. It takes you to do that, but the other way around is to multiply by that 2.
Okay.
All right. So these are, you find them not much, 2 marks, you know. Then this is the common version that they bring. Let me show you now this one, where they will say the volume of a solid is given by, they give you something like that. So the volume is v is 4 over 3 pi r cubed. Then it says change the subject of the formula. You see that? So here you get your v is equal to 4 over 3 pi r cubed. See that? Now they say what? Change the subject of the formula to r. They want you to make r. So now what do? As I say, you can just simple divide here by what you don't want, which is the 4 over 3 pi. Nothing is wrong. And then you divide here by the 4 over 3 pi. But in a way, as I say, it doesn't look professionally right, you know. Like in a way, in mathematics, we say it was not right. First of all, just get rid of that 3 on its own. So what you do, multiply here by 3 on this side, and then here also do by 3.
Okay.
You see, so you multiply, you're multiplying by 3, you multiply by 3. Why? Because the 3 here is at the bottom, you multiply, you see, that's how it goes. You see that? So then 3 times v, you have got 3v is equal to, then you have got 4 pi, sorry, yes, this is right, it's right actually, 4 pi r cubed. So the 3 is gone. That is how you remove a fraction, you multiply by that. Then from there, you see, you divide, that's why now you divide by 4 pi instead. Then what you do on the left again, you do on the right, divide by 4 pi. The 4 goes and the pi goes. Then when you look at that, what you have now is 3v over 4 pi is equal to r cubed. Just like the r squared, what you do from here is still the same. You find the cube root now. Because it was 3, is the cube root, is power. So even here, you find the cube root. Just like that. You understand? So now, when you do that, say equal to, then you get r. So what to be, actually, you can start now by saying, therefore, here, r is equal to, then you have got cube root of 3 v over 4 pi. You know? So that is the first part, to say change the subject of the formula, and then they say calculate r. That's like, they like that now. If v is that, then you come back and say, okay, r is equal to cube root of 3. They told you your v now, which is what? 147. See, there is your v. Then over 4 pi, and pi is just a number. Then that's when you can then apply a calculator to then get the final answer into that, you know. So let me just see if my calculator can come here. So it's shift, there you've got cube root of fraction there, and then you've got 3 times 147 over 4 times shift pi. There is my pi there. Then you say equal to, then you get 2 decimal place, shift setup, there is number 6 of fix, and then 2 decimal places if you want, that is 3,27. But now you see, you must be careful now. They say calculate R. So it's 3,27. So I'm going to say which is equal to 3,27. But R is distance. Remember, it's the radius. Then you must leave your answer in meters.
Oh.
You understand? Don't just leave it like that, because it's a distance. You must tell us the units. They told you the volume is cubic meters, but now R must be in meters then. You know, those small things. But they don't really penalize you if you forget that.
Yeah.
They don't penalize. But I'm just saying, to be relevant and being correct, don't leave your answer without units unless whatever you're giving doesn't have units. Yes. So that is that part. Any questions?
I'll have to look at these in my own time again eventually, because these are the things I'm really struggling with.
Okay, all right.
Yeah.
Okay.
But
now
I'll look at it again.
Please, get time. To me, as I said, this is your, what can I say? To me, is the foundation of algebra to say, why do I do what I do? You know, for example, I've got a 3 there. How can I get it away? I've got 4 there. What do I do? I've got a pi there. I've got a cube there. So all these are kind of things that, you know, should I get a cubed? What do I do? Should I get a fraction? What do I do? All those kind of things.
Right.
All right. So yeah, bring those are the things. Also on our last day, bring in some example. Try something on your own. Bring it to me, and then we just play around it and see how different options could have been done.
Yeah.
All right. So there is another one. It says solve the following. Now we're in equations now. You know, and with equations, as I say, it's like the subject of the formula, but here you are making x the subject. X.
Okay.
Yeah. So in a way, this is the basic equation whereby you have got 8x plus 6 is equal to 3x minus 14. So it's the base, right? So from here, what do? You are looking at bringing the x's together. So you take this 3x that side, because it joins the x. It was positive, it will become negative. So from positive, it will become negative because of the what? Equal sign. And make bigger. So also, what you see here is, look at 6. 6 also must join the number 14 there. So it's positive, crosses the sign, it becomes negative. Those are things that you must just be careful of. So what you have here, you will have your 8x minus your 3x, right, is equal to, now already 14 is negative. You see that? So it's minus 14, but 6 was positive, it becomes minus 6. Right? Now 8 minus 3, it's 5x, right, is equal to minus 14 minus 6. I think you'll get negative 20 there. Then when you do that, how do you get x? You divide by what you don't want there, because that's the x you want to remain with. So you see here, x is multiplying. I know you might be saying, I understand here, not problem, but it's 5 times x. In a way, that's what you're having. So how do you, what's the opposite of times? It's division. That's why we divide by 5.
Okay.
You know, just in general. So here what you'll be having is 5x. I cannot say take 5 to the other side. It can't, because there is a multiplication there. There is a glue that is holding it together. And the glue is a multiplication, so you can only divide. You know. So when you do that, you've got your x is equal to 5 into 20. It's 4, and there is negative 4. Right? And with equations, man, all the equations you're going to do, please test them. Test them. So what you do, you take a calculator. Where there is x here, you put your minus 4. Where there is x here, you put your minus 4. Isn't you're saying x is minus 4? So you look at the left hand side. So this is what you do. You take your calculator, where it will have, you have to calculate the left hand side and the right hand side. Okay, let me just bring my calculator here. Look at what I do. So I start with the left hand side. I will say 8 bracket x is minus 4, and then plus 6. They need to give me an answer. I'm getting minus 26 on the left hand side. So I do again the right hand side. It will be seeing whether it will give me this minus 26. So it's 3 bracket minus 4, close the bracket, minus 14. There it is. I'm getting again minus 20. So the left hand side is balancing the right hand side. My equation is correct. Those are things that you cannot move on without testing, because you can make a small error, but you need to correct that immediately. So don't find yourself just failing to just quick test and then move on with the other questions.
Okay.
All right, look at this one. Here we are also solving, and when you're solving, brackets are very important. I think you remember this BODMAS issue, and they always say BODMAS means brackets are very important first. B for brackets, so meaning open those brackets, and the 4 multiplies everything there. Again, on the other side, there is a 2 affecting everything there. Are you seeing that? So 4 times x is my 4x. 4 times negative 3 is negative 12. Then minus 6x is on its own there. Nothing is affecting it. Is equal to 2 times x is 2x. And then 2 times 4 is 8. Then from there, collect my like terms. Meaning, my aim is to focus on the x. There is the x, there is the x, and there is the x. See that? So now I have 4x already, it's fine. It's on the left hand side. Minus 6x, these are fine. But look at 2x, I must cross it this side. So it was positive, it will become minus. All those things are very key. You see?
Okay.
Then I'm done with that. Focus on the numbers. The numbers, I've got minus 12 and 8. Those are the 2 numbers. So which means it will be equal to 8. Negative 12 becomes positive 12. You know. So that is the main things. Just, it's a matter of being careful with your science, more than anything here. So we are saying now 4 minus 6x, 4x minus 6x minus this. I think with the calculator here to give you minus 4x. Yeah. Because it's 4 minus 6 minus 2, right?
Yeah, you're right.
Is equal to 8 plus 12 is 20. Then divide by what you don't want. Please don't divide by 4. No. Divide by negative 4. Those are 2 different things. So sometimes you might think I'm dividing by 4, but there is a negative there. Respect it there. So that you don't want even this negative. Just like you don't want this 4. Even the negative is a problem there. So even here, and then what is your x there? It will be negative 5. Negative 5. Now, quickly test this for me with your calculator. Where there is x here, we put negative 5. We put negative 5. Chest for me the left hand side and tell me what you're getting on the left hand side. So 4 bracket minus 5 minus 3, close the bracket.
5 minus 3,
close the bracket. Minus 6 bracket because it's multiplying, or you can say minus 6 times minus 5 because x is minus 5.
Times minus 5.
What is it giving you?
It's giving me minus 2.
Minus 2. Let's go to the other side. That is the right hand side. 2 bracket minus 5 plus 2.
Minus 5
plus 4.
Plus 4. Minus 2 as well.
See, minus 2. So what does it say? My left hand side is equal to my right hand side. It means I'm correct. So those are things, man. I'll say, Martin, I think you've seen I make errors myself, I'll continue writing something, but I forget things along the way. So because I know I'm prone to making errors, especially on my side, I also struggle with errors, man. And you think you're working properly, and then all of a sudden you're no longer putting that square or whatever. It's just got lost along the way. Not that you didn't know, but you forgot it, So what you do is test your answers, man.
I've also picked up on when I would write the equation down before I do the whole thing.
Yes.
I would also find that I mix something up somewhere, and then
Thank you. Yes.
Like the plus and the minus or whatever, and
it's true, man. But what did I do? Like you're asking yourself, what were you thinking? I mean, you're asking, I don't know who you'll be asking also, but what were you thinking writing this? Whether it's the hand having its own thoughts now,
So I also find myself sometimes mixing things up, and
it's true, man. It's true. It's funny how the mind does that, or the hand, and without picking up, and then testing now and please, when you're testing, right, please do this for me. When you test, don't test on what you wrote. Please go to the original. See, come here on the original. Why? Because the original has not been infected by you, my man. It doesn't have COVID, man. It doesn't have COVID, you know what I mean? So it's still clean. So don't use these tests. You're testing here, but this guy, what if you already made errors here? You are testing on the wrong thing, you know what I mean?
Yeah.
So please,
Even like the squares, sometimes you miss the square.
you miss the square, and the whole thing, you are asking where is, and actually you'll be going back and you won't even see what is missing, until that's why I'm saying just test your answer, especially equations. You will know that I didn't do it right.
Okay.
You will be knowing. All right, so those equations, again, give them a trial. It will actually be beneficial to you. All right, look at this one. Now we are looking at a different part. Now this is speed, distance, and time. All right. Now in your in your formulas, I didn't check well, but I don't think they give you the formulas for that. But I think through your science, you must remember this. Whenever you come to speed, distance, and time, you remember this triangle. It makes things better, to say speed is what? Is distance over time. Then you've got speed there.
Yeah.
So it's always good to remember this triangle. Speed is distance over time. You can find everything here. Time is what? Time is distance over speed. And then distance is speed times time. You understand this one, am I right?
Yeah.
All right.
Yeah.
So here they're saying, at what speed did you travel if it took you 8 hours to cover 9,000 kilometers? All right. So you are saying, okay, I'm looking for speed because they are asking you at what speed. So speed, question mark. And then time is what? Is 8 hours. Now, what I want you to be careful of, look for SI units here. Always try to deal with SI units, or be careful of units. Okay. Now, what am I saying now here? If I give you minutes, please, minutes are not SI units. You must convert them to hours, please.
Okay.
Please always remember that. If I give you seconds, always make sure that on distance you're working with meters.
Oh.
You can't work seconds with kilometers. So seconds will link you to meters, just like hours will link you to kilometers. Because when you look at the speedometer, it says kilometers per hour. You understand? So always be careful how they are trying to play you around. So 8 hours is fine. And then you've got distance here, which is 9,000 kilometers. All right. Then the question says what? They want us to calculate speed. So you use here to say speed. Please, this is how you write it now in the exam. Speed is equal to, you write that formula. Please don't take it for granted. There is a mark for that formula over time. All right. Which is equal to, my distance is 9,000. And my time is what? Is 8. Then you get your final answer there. Let's do that and see what it gives me. So it will be 9,000 divided by 8. Alright. What am I getting? 1125. So it's 1125. But please, units. 9,000 was kilometers. 8 was hours. So you see, it's kilometers per hour. Why? It's even speed, Even your logic will tell you the speedometer must be either in meters per second or kilometers per hour.
Okay.
You understand? So those small things, please don't leave them out, because they might be sensitive now on the units. Don't just leave it as 1,125 watt. All right.
Yeah.
Okay. Now, this is the one I want you to focus on, because it's a bit of it's not tricky, but it needs you to think in a way, as you see. Let's read it out. It says a motorbike covers 120 kilometers, right? Then it says in 1 hour 15 minutes. You see, they have mixed units now. There's an hour, there's a minute. Then it says calculate the time in hours and minutes it takes to cover 250 kilometers if the average speed remains unchanged, right? And we say, the moment they say speed and everything, just bring this guy in. It will always help you to say, okay, draw that, and then you say speed is distance over time. So now, first of all, is if they are telling us if the average speed remains unchanged. Let's calculate it now. What is speed? Speed, we're saying, is distance over time. which is equal to, let's start with the first story here.
Okay.
On the first one here, it says a motorbike covers 120 kilometers, so it's 120, and then in 1 hour 15 minutes, there it comes now. You ask yourself, but I can't say over 1 hour 15 now. You're like,
Yeah.
what is this 1 hour 15 minutes? Meaning, convert this 15 minutes to hours. You divide by 60.
Okay.
Alright, can you do that for me? If you can divide that for me, what is it giving you?
15
divided by 60.
0.25.
0.25. So it's 1. So which means it's 1 hour 15 minutes. It's 1 plus 0.25, which is equal to 1.25 hours. You understand? So here I'm going to divide by 1.25. Okay. So then can you now give me the answer then when I'm dividing that? What is my speed?
20 divided by 1.25 is 96 kilometers an hour.
Now 96 kilometers per hour. Right. So they said this speed remains unchanged. So which means the car maintained 96 kilometers per hour. So now they are saying, let's come back here. They are saying calculate the time in hours and minutes it takes to cover. Now there's a new distance now. From 120 is 250 now. Right.
Okay.
So they want time. So they are saying calculate the time, which means from my triangle here, you can see what is time. It says what? Time here. The formula, time is distance over speed. It's very important to write that, which is equal to my distance, they told us, is what? 250. And the speed never changed. Right, and the speed never changed. Is still what? 96. And then what will be the time for? Please check that for me.
250
divided by 96.
96. It's 2.604.
2.604. Okay,
Yeah.
I like that now. Look, remember time. What is this 2.604? Remember we said distance is in kilometers. Now this is kilometers per hour. So which means time is in hours. Now you have a problem now. The question said calculate the time in hours and minutes, which means you need to convert this portion, this point, this one. So what you do is, already you know 2 hours is set up, it traveled 2 hours, but what is this 0.604? These are hours, right? Then you multiply them by 60 this time. Remember, here you divided by 60. Minutes to hours you're dividing. But now we are moving from hours to minutes. We are multiplying. We are undoing what we did. So the opposite of division here is multiplication here.
Okay.
So you say 0.604 times 60.
That gives me 36.24.
36.24. Now you can see you can leave this is now even further. So the answer is 2 hours 36 minutes.
24 seconds, I presume. Yeah.
No, now back again. What you do is, if they say it with seconds, you're like, okay, I've got this one comma, which is comma 24, which is 0.24. It's minutes now. Multiply by 60 to change from minutes to seconds now. Just like you multiplied by 60 the 0.604 hours. So what can you multiply that by 60? The 0.24.
0.24 times 60 equals 14.4.
Thank you. So it will be 2 hours 36 minutes 14 sec.
Okay.
You understand? Because these are, if you say to me it's 36.24 minutes, so it means this is 0.24 minutes. It's still in minutes. To convert it, minutes are always larger than seconds. Multiply by 60.
Okay.
You understand? But that is a good one also to indicate that. Sometimes they will say minutes, hours, minutes and seconds. So you see how you go from hours is already done, but now from here, from these hours, multiply by 60, you get your minutes. Again, from minutes, multiply by 60, you get your seconds.
Okay.
You see the whole thing. But now, another thing that is a bit, let me show you this quick one here. I'm not going to take much of your time. You know, the answer here was this. We agreed it's 2 hours, 36 minutes. But I want to show you something called proportion here on this question. It says a motorbike covers 120 kilometers in 1 hour 50 minutes. I can write it like this: 120 kilometers is to 1 hour 15 minutes, and then we said it was 1,25. Am I right?
Yeah.
It was 1,25 if I'm not mistaken. So 120 takes 1,25 hours. See that? Now they say calculate the time in this, it takes 250. Then you say, what about 250 kilometers is to what? Is to what I don't know, x. You see, then after that, you do this, cross multiply. You say x times 120, which is 120x, is equal to 250 times this, which is 250 times 1,25. Right? But you want your x here. You divide by 120, divide by is proportion, 120. Can you do that for me?
Sure.
So I say x is equal to 250 times 1,25 over 120.
Equals divide by
120.
20. 2.604. I have 2.604.
Which is what we got in the previous, remember that 2.604. You see that? So it's still proportion. If you, it's not like you needed to know the formulas. If you can see, if I say he moves from this, he took this, what about if he moved this distance? They ask questions like this. They will say, if 2 men can dig a hole in 3 days, how about 5 men? You see those kind of questions. So they are saying, like here, they will say 2 men can dig a hole in, let's say, 5 days, because they are 2. So this is 2 men. And then they'll ask you, how about 5 men? How many days will they take? So you say is to x. Then you cross multiply like this. And then you say 2 times x, it is 2x, is equal to 5 times 5, which is 25. Then you divide by 2, you divide by, am I doing this right? What did I say? 2 men take what? 5 days, right?
Yeah, no, it's correct, yeah.
Is it correct? I'm cross multiplying.
2 times x is 2x, and then 5 times 5
times 5. Okay, now I'm dividing by 2 there, and then you cancel the x, but I'm getting something. 5 men are taking more days. I expected it to go, this is the other way around. The 5 men must take even lesser days. Remember now, it must take lesser days. So what you have is, it's actually 5 over 2. You multiply, it's what? Sorry. It's 2 over 5. You multiply by 5 days, because they must take even less days, which is what? Which is 2 days now.
2 days.
Yeah. But those are kind of question of proportion. Are you with me?
Okay.
Yeah.
I
so,
see it,
but this was fine. Distance, speed, distance. You can use that formula in those. All right. And then, having done that, let's look at some word problems now. This is where they will also bring you some tricky with some word problems. Here they are saying, word problem: 6 times the sum of 8 and a certain number equals 60. Then they say determine the uncertain number. But let's do it one step at a time. They are saying 6 times. You must also come up and say, what is this 6 times? It's saying this 6 times.
Okay.
Because times means multiplication.
Yeah.
So 6 times the sum of what? What does sum mean? Sum means plus. Sum of, 6 times the sum of 8, there is 8 and a certain number. That word certain number, you can call it x, we don't know the number, equals, there is an equal sign, 60. So they are saying, if I take 6, then I multiply the sum. What is a sum? Sum means 8 plus a certain number x. I must get what? 60. But whenever I say times here, I'm forced to put a bracket like that. Because this 6 times the sum here, I must first add these 2 numbers before I can multiply them by 6. That's what I'm saying.
Yeah.
You understand? Okay. So 6 times the sum of 8 and a certain number. So 6 times, first of all, have the sum of 8 and a certain number. So the sum of 8 and a certain number. So how do you say? You say let the certain number be equal to x. You see? So we say 8 plus a certain number, which is x. Then that number I multiply by 6. I must get 60. You see? Then from there, you have to do what is called opening the bracket here. You open that. You open that. If you want, you could have divided by 6 on both sides, but this is still fine. So what you have is 6 times 8, I think is 48. 6 times x is plus 6x is equal to 60. Then from there, take 48 to join positive, negative. You have got 6x is equal to 60 minus 48. See that? And then from there, if you say 6x is equal to 6 minus 48, I don't know what to get on a calculator there. I think if you can subtract this, 12 or so. Check for me.
48 is 12,
12, okay. Then after that, I've got 6 there. I must divide on both sides. So you've got x here is equal to 2. So if you read this statement, it says now 6 times the sum of 8 and the certain number. So the sum of 8 and 2. So if I say 8 plus 2 and I multiply that sum, what is 8 plus 2? 8 plus 2 is 10. And I multiply 10 times 6. I get what? I get 60.
Yep, correct.
Are you fine?
Yeah,
I know this word problems. Well, personally, I'll say look at this.
Confusing.
Personally, I say students who feel like sometimes this thing, because it's more of English jargon and stuff, I say don't stress over this. It's 4 marks, sometimes 3 marks. You don't have to spend a lot of your time on this section, man. You know, because they always bring it in different angles and everything. So I won't say, if you ask me to say, will you advise me to go and bring more questions of this? I will say, not really, better bring us something that we are guaranteed on algebra, on equations and those things. If you bring in more of these, not that you are wasting time, but you should have been studying other things that was going to give you a better quality mark. Because this can only give you a maximum of 3 or 4 marks, you know. But with equations, you can find a question, maybe 2 questions on equations, giving you 10 marks total of those. So I think it's worth going for other areas, you know. But now let's look at this one. It says the difference word there. The word difference means minus. Right. So the difference between, the difference between 15 times, there is the times again. The difference between 15 times a number. So when they say a number there, you let the number be what? Be x. Let the number be x. So the difference between 15 times x and what? And 3000 is 0. So let me read in full. The difference between 15 times a number and 3000 is 0. So what is 15 times a number? Is 15 times x, which is 15x. So they are saying the difference, which is minus, the difference between 15 times a number and 3000. So the difference between these two numbers, minus 3000, is 0. There, equal to 0. What is the number? That's all, man. So they are saying 15x minus 3000 is equal to, the difference is what? The difference is 0. Then after that, take 3000 this side, is 15x is equal to 3000. Then you divide by 15 to solve for x. Then I don't know what to get there, but I think it will give us 200. Yeah. So the answer then becomes 200. So if I say the difference between 15 times a number, the number there is 200. 15 times 200 and 3000 is 0. You know that thing. But as I say, can bring more. I'm not discouraging you. If you know that you want to know them better, bring them more. We can always kind of find some solution towards that. All right. Now, that was the first part, the first section of our lesson. The last one here is on graphs. I don't know whether you want me to take a short break with you.
No, I'm still good. We can continue if you want to.
Yes, we can continue. All right. Now, let's look at this question now.
Okay.
It's a These are graphs now. It says given 5.9, you are given x over minus 2 plus y over 3 is equal to 1, right? And then 5.9.1, they says write the equation in standard form. Now let's come back to this whole thing of equations and graphs. When you're talking about graphs, just to give you a heads up, when you say a straight line graph, remember y is equal to mx plus c. This is the standard form. That's what they mean here.
Yeah.
Right. So y is equal to mx plus c. What does it mean? Now you need to know what each one mean. Now whenever looking at this particular c, it means the y intercept.
Okay.
That's what it means. What is the intercept? It means it crosses at y-axis. Sometimes they also call it the constant. This one. So they can call it the y-intercept and the constant. And then the m there is the what? Is the gradient. That's your gradient. So don't forget those things.
Okay.
That's what they usually will be asking for you there. So now this question is 2 marks. They are saying here on this question, you are given this one, and then says write the equation in standard form. So look at this. They gave you this to say you have got x over negative 2 plus y over 3 is equal to 1. So now we are back on fractions now. I need to get rid of these fractions here. So I'm looking for a number that can go into 2 and 3, and the nearest number is 6. You see, 6 can go into 2 and 6 can go into 3. So which means I just have to multiply this by 6. I multiply this by 6. I multiply that by 6. Each and every item, as long as there's a plus, minus, as well as an equal sign. So now that's how I can simplify that. So when I multiply by 6, by 6, by 6, what do? This 2 goes into 6 how many times? 3 times. 3 goes into 6 how many times? 2 times. You see that?
Yeah.
So now I say 3 times. Remember there's a negative at the bottom. So it means here I was supposed to say actually negative 3. Negative 2 into 6 is negative 3. So now I have got negative 3 times x, which is minus 3x, right? Y times 2 is plus 2y. 1 times 6 is equal to 6. We're not yet there. Standard form says what? Y is equal to mx plus c, meaning y is the subject of the formula. So what you do is you take this 3, negative 3x, let it jump the equal sign. So it's negative. When it jumps, it will become positive.
Yeah.
So it will become 2y is equal to, since you are saying y is equal to mx, x must start. So here I'll start with negative 3x is now 3x, then plus 6 because it was a positive 6.
Okay.
Are you seeing that? But still we're not done. It's still having a 2 there. That 2 is a problem. You divide it by 2, 1. Now this is how you do it on the other side. Don't use this one. Don't say all over 2 like that. What you need, it will affect this equation y is mx plus c. So what you do is you divide it individually. So you say here over 2 and then you say over 2. So that each one you are dividing by 2. So the 2 cancels there, and then you are going to have y is equal to 3 over 2. This one remains as is 3 over 2x. Now 6 and 2 gives you a 3. Then it's plus 3. This again, it comes back to that thing when you said, when you said to me this thing about the subject of formula. Remember those words. So when you master it, you see that concept is needed there. When you said I need to do more problems on those subject of formula, make x the subject, make what. So that's what you're doing actually here. We are making y the subject of the formula. That's how important it is.
Okay.
So now, what is this now? This is the standard form they're talking about. Write the equation in standard form. It looked funny at first, but it's a matter of getting rid of the negative 2 and 3 and also making y the what? The subject of the
subject.
That is one way. Another way, maybe I made it a bit hard. Another way you could have done this. Let me show you. It can be another option. You are focusing on your y, so you are saying you're saying x over minus 2 plus y over 3 is equal to 1. The aim, remember, is to focus on y. So we can take this minus this side, it goes this side. It will become positive because this minus is as good as is there.
Okay.
Yes. Whether you set if I take a calculator and I say to you, I've got, let me just show you. If I say to you 1 over minus 2, look at the answer. It's still minus 1 over 2. So it doesn't matter wherever it appears, but it makes everything negative. So here I'll have y over 3 is equal to, from negative it will become x over 2 and then plus 1. See that?
Oh yeah, okay.
So now already I must now get rid of that 3, because so how do I get rid of 3? Multiply by 3 here, even here multiply by 3, even 1 multiply by 3. See that? So that these 3 goes now. So I will have what? Y is equal to, when it's multiplying by 3, is more like 3 over 2. So you have got 3 over 2x. 1 times 3 is plus 3. Then it becomes also a complete thing.
Okay. I just want to ask you, so if you put this equation, your answer here, into the formula, the y equals mx plus c, how would you put it in there?
Come again, repeat. Can you rephrase again? If you put
if you put y equals 3 over 2x plus 3 into the equation in standard form, how would you put it in?
If they say standard form, they are saying, isn't this y is called mx plus c? So if I come here and say y, let me write the standard form, y is equal to mx plus c. Now what you are trying to say is 3 is c, x is x, and m is 3 over 2.
Okay.
You understand? Right. So when they say put it in standard form, they are trying to say we want to see the gradient, there is the m. We want to see c, there is c. But when it was like this, things were just mixed up. We don't know what is m, we don't know what is c, because everything is just mixed up here. But by putting it in a standard form like this, I'm able to say, oh, so this is the m there and this is the c.
Okay.
Hence, look at the following questions here. It says 5.9.2 and this 1 mark, determine the gradient and then determine the y-intercept. So here, when they ask you of the gradient, you just now state there is the gradient. You just say m is equal to 3 over 2 after that question. Then the y-intercept, c is equal to 3. You just state that now, but it flows from the first question.
Okay.
Is it making sense then?
Yeah, definitely.
And then let's look at this other one again. Let me erase a few things here just to look at that. 5.10. It says here you are given xy is equal to minus 3, right? And then point 1 says write the equation in standard form. There is another type of a standard form. Now whenever you see xy together like this, xy multiplying, just know the actual equation in standard form is like this: y is equal to a over x. A can be any number. This is a hyperbola. This is a hyperbola. Alright, so you must always know that's the general equation of a hyperbola. So how do you go about then on this one? So if they say xy here, let me just take something different. Xy is equal to minus 3. So your duty is to let y alone. So what you do, divide by x on both sides, so that you are left with y. So y is equal to minus 3 over x. You see, so you have made it similar. Y is y there, x is x, and then a is that minus 3. See, this a is now represented by this part, minus 3. So if they say write it in standard form, they are saying this is the answer, this is the standard form. You understand? So it must follow this rule, whereby we want to see y, there is y. We want to see x at the bottom, there is x at the bottom. give us the value for a, which is the minus 3 there.
Okay.
Are you with me?
Alright.
And then
Yeah,
they will
yeah.
say this, man. In which quadrant is the graph drawn? 2 marks. They made it 2 marks. Now this graph is like this. If I give you this graph of a hyperbola, there are two portions of this graph. The first one is like this. Let me just sketch here my quadrants, two of them, so that you can have a distinction. So remember, this will be your y and your x,
Yeah.
and then this will be your y and your x. So now, if they say sketch the graph, the first one, okay, the quadrants they do like this. You number them anti-clockwise, like this.
Yeah.
So you have got quadrant 1, quadrant 2, we start from x, then quadrant 3, and quadrant 4. Alright, anti-clockwise. So if they say draw the graph, so there are two portions of the graph. Is either they are here in quadrant 1 and quadrant 3. Please, when you're sketching them, they must never touch the lines. If they touch the line, they will penalize you. So make sure that it doesn't touch the line and it doesn't touch that line. And don't do it like this. They will still penalize you. Let me make it out. If you draw like this, like a straight line, and you're like this, you can see that this thing is gonna touch at the end, because where is it gonna go? You can now do this now, you see. So you need to what? You need to curve it nicely to say, and don't do this, man. Now you are saying it's running away. At the end, it's like it's a circle, you see. So it must be about to touch, comes here and is about to touch, because it continues forever like that. Then you have an arrow. You have an arrow. It will never touch, but it will get as close as possible. You understand?
Okay.
So even here, avoid this thing of curving up like this, and then you find that it's curving up. Then they will penalize you. They will penalize you to say the shape is wrong. Are you with me?
Yeah.
So you must have it nicely to say it was not touching but curving nicely, not touching but curving nicely. So this is quadrant 1 and 3. Then the other graph will be here in quadrant number 2 and 4. That's where you expect the two graphs. So it will be like this and like this. That's where you expect the two graphs. Either 1 and 3 or 2 and 4. You'll never find them in 1 and 2. You'll never find them in 3 and 4. So you won't find a thing like this to say I'm drawing one there and I'm drawing one there. No, this doesn't exist. So then when they say now which one is which, in this case you are going to ask me, then which one is which? Then I'll tell you on the general form. Remember, the formula says y is equal to a over x. Now when a is positive, you'll get this one. And then if I say y is equal to minus a over x, you'll get this type. When you see a negative, you get this type, 2, 4. So the negative deals with 2 and number 4. Are you with me? And then the positive deals with 1 and 3.
Okay.
So here, that's why they ask this question. In which quadrant is the graph drawn? You see, there is a negative. So you must actually remind yourself of the sketch. If it's negative, then it will be quadrant 2 and 4. So here you're supposed to say in which quadrant it was. You're supposed to say quadrant 2, and you can write them like that, 4. Or you can use this way, 2 and 4. They will still anyway. And then what is the name of the graph? We did mention to say this graph is a what? Is a hyperbola. Are you with me? So that is that part of these graphs. And then last one on these ones before we do actual sketching, it says 5.1.1 given 4x plus 2y plus 3 is equal to 0. You see, they mix it up. Then they say write the equation in standard form. So don't forget, standard form says what? Y is equal to mx plus c, meaning you make y the subject of the formula here. In other ways, you are going to remain with y. So look at it. I've got 2y there already. I must take everything to the other side of the equation. So what will I do? I would say 2y is equal to 4x will become minus 4x. 3 will become minus 3. Not bad. But I'm still having 2y. That's not standard. I must have y. Then I must get rid of that 2 by division. divide by 2, but please on the right hand side, don't say divide by 2 like that. It's not gonna be standard. You must do individually. Divide by 2, divide by 2, so that you can have mx plus c. So you will have y is equal to the 2 into 4 there, it's 2, it's minus 2x. Then c there is minus 3 over 2. Or you can say minus 1.5. Then the next one is determine the gradient. Then you come here and say, okay, from this one, y is equal to, and then we say what? mx plus c. Where is the gradient? There is the gradient.
Minus 2.
Yes, so m is equal to minus 2. And then determine the y-intercept. There is the y-intercept. Not just 3 over 2, but what? Minus 3 over 2.
Yeah, see there, that minus.
Yes, see. You'll be quick to say 3 over 2, but there is a minus before it, because the minus belongs to 3 over 2 there. Alright, and then last one on this one says, given xy minus 6 equal to 0, write the equation again in standard form. Standard form meaning take 6 to the other side first. Remember, the standard form says y is equal to a over x. X must be at the bottom. So you take 6 to the other side, it will be xy is equal to 6, which is positive 6. And then from there, you don't want x there. Divide by x, divide by x. Then you will have your y is equal to 6 over x. You see that this thing is positive. Then they're asking you which quadrants. Remember, when it's positive, it's quadrant 1 and 3. When it's negative, it's quadrant 2, because why? There is a positive there. The fact that I can't say a negative, it means it's positive. Then when it was negative, then it was going to be the opposite, quadrants 2 and 4. Alright, so that is that part that we are having here. And the second session now, what it does, it deals with the actual sketching, of this graph now, whereby you literally have to sketch a straight line graph. For example, says use the table method to draw the graph of 2y is equal to minus 4x plus 8 for the domain. This is the domain on graph paper. Then it says all values at the points of intersection with the system of axes must be shown. I just want you to do this for you and show you the most sensitive things here. First of all, it says use the table method. And what is the table method? You do this, you come up with a table, right? And you look, they gave you the values to start from. So you come up with a table like this. And I don't know whether I'll divide it into equal numbers. Let me just do it at random for now.
Okay.
So they are saying, remember, x is on top here. And here is what? It's y.
Y.
Are you with me? So now they told you the domain is x, please. Domain is always x. So they're saying, where are you starting from? You see, that's why there's an x there. Minus 4. So you say minus 4. And then you say minus 3. Then you've got minus 2. Then you've got minus 1. Then you've got 0, 1, 2. That was perfect. It fit. Right. Then from here, now look how they confused you. They gave you this equation. They said to you 2y is equal to minus 4x plus 8. You see, they were tricking you here because the y has 2 in it. It's not just y. So first of all, divide by 2 here and then divide by 2 there so that you change it into a standard form. You see? Then you divide there. So you've got y is equal to 2 into 4 is minus 2x plus 2 into 8 is 4. That was very important.
Then, that's a tricky one.
Then you can now come here and say, let me now start substituting. Here, x is what? Minus 4. You see that? Then if you can use a calculator, try for me. Minus 2 bracket minus 4 plus 4. And if it gives you minus 2 bracket negative 4. Start with negative 4. And then plus 4.
Plus 4 gives me a 0. Let me just do it again.
Minus 2.
Okay, it's minus 2.
Bracket. Negative 4. Close the bracket. And then plus 4.
Plus 4. 12.
It gave you a 12.
Yeah,
All
gave me
right, so
12.
let's start there, say 12. Now play back and put -3 instead of -4. Play back.
Sorry, I pressed the wrong
Okay,
button, so I can't.
so
Okay,
it's
let me just do it again.
-2 bracket.
Minus
Now it's
2
-3
bracket, minus 3
bracket
bracket,
+4.
plus 4 equals 10.
10. Okay, play back and do -2.
Minus 2 equals 8.
Okay, -1.
Minus 1 gives us 6.
6. And then 0.
0 gives us
4.
4.
Yes, and 1.
1 gives us 2.
2 and 2, I think, will give us 0. Yeah.
0.
So you see, I think even from here, you must also be careful for the flow. It makes sense. 12, 10, 8, 6, 4, 2, 0. It does make sense, Now, from here, the question was, what must we do? Says use the table method. So that's what they wanted. But please don't forget, you needed to divide first by 2.
That's a very important one that they would catch me there.
Yeah. So that you don't find yourself saying -4 bracket, you put -4 plus 8, forgetting that the 2y is not y there, it's actually what? 2y. So that was what you supposed. Always look at it, is it in standard form? Is it y? Not something before y. Is it in standard form? That's why they emphasize first express it as a standard form. So that concept we were learning previously is now part of this now here. Alright, and then from there, it's a matter of sketching. I think if I can try to see here on my graph, I hope it will show. My graphs might not show as much as I wanted it. Okay, I think I'll try here. Okay, I think there is a graph paper that can try. Let me try copy this to the side and see if it can come this side. It doesn't want to move.
No, it doesn't want to.
Let me try it again. Let me just duplicate it and take it away like this. Okay. So, right. So, but I think on your side, personally, is the sketching a problem though? Like
No,
this one.
no.
This one is not an issue.
I was actually looking at the sketching of the straight line graphs today.
Yeah. How is it?
And no, I don't think it's really a problem for me.
It's not a problem, right?
It's just, but very important is that one where you showed me now the 2y, because
Yes.
I wouldn't see the 2y,
Okay,
so it's really good that you showed me that one.
Yes, please don't forget that. And there is one thing I wanted to show you. It says all values. Okay, let me first do this so that I can show you where you must be sensitive with your marks, because there is something they're emphasizing there. But let me just quickly just show you where, whenever you are sketching it, I'll say be careful here, they're going to penalize you. Let's say we were plotting it. I'll just do this one. The other ones, I think, is a matter of you then practicing. So let's say you have got this. Remember, this is your y-axis. Please label them. They'll penalize you there again. Okay. And then you've got your x. Right. And then we said our y is starting from, this is 0. So you've got 1, 2, 3. Okay, actually, you need more thing on y, because you see it's from 12. So if I can maybe move by, okay, I see now, actually this thing is not gonna work for me. Let me do it like this. Just wanna show you something. Look at the y values. I don't have any negative values. They start from 0. So I can actually have my graph in a way starting all the way from like this down here, because I've got more positive. You see, so that I can have, here is my x, so that I've got 0, maybe 2, 4, 6, 8, 10, 12. So this one you're fine. And then the other one is for x is -1. Let's use that one. -2, -3, -4, and 1 here, 2 and 3. I think that was the end. So now if I can quickly put these values, -4 is 12, so there is one there, and then -3 is 10, there is another one there, -2 is 8, there is another one there, then -1 is 6, I think that is it, and then 0 is 4, there it is, and 1 is what? I think 1 is 2 there, 1 was 2, and 2 was 0. Yeah, just wanted to emphasize a few things here. So I'm going to draw a straight line, which is more like that. Try to make it straight. So this is the graph. Now look what we mustn't forget. Don't forget to label the graph. This is the graph. Go back to the list. What is it? 2y is equal to minus 4x plus 8. Go and label it. Don't leave it like that. So you're going to say this is my 2y is equal to 4x plus 8. I don't know if I didn't make a mistake. That's very important. Number 2, they say to you here, all the values, see, they put all at the point of intersection with the system of x's must be shown. All the values of intersection. So meaning when you see any part that it is cutting, they need that to be clear. That 4 must be very clear there. And then that 2 must be very clear there. And then in other places they will say all the values of the coordinates of the point of intersection. If they say coordinates, you come here and you say, what is the coordinate here? X is 0, y is 4. They want to see that in coordinate form. If they say coordinates. And then here, x is 2, y is 0. If they say coordinates, please leave your answer like that. If you forget it, there is a mark there, there is a mark there. They'll mark you up. But here, because they say all values, 4 is a value, not in coordinates, and 2 is a value. That must be very visible. So when what they'll do is, when they are marking, number 1, they'll say they'll mark the shape of the graph, which is a straight line. They give you a mark. Did you label the graph? There are 3 things on the labeling. Did you see? Did you label this as your y, that as your x, and did you label the graph itself?
Okay.
Right, and then they'll check your scale. Is your scale for the y-axis and the x-axis correct? Then for you to get the 5 marks, they'll be looking for all these things, So just make sure that it's not really about coming with a straight line and leaving it like that. Just make sure that the points are visible, your scale is visible, the x-axis are labeled, and your graph is labeled.
Okay.
Those are the things that I just wanted to bring across. All right. And then I think if you're saying not a problem, even here, I think this one also might not then be a problem with you. Look at this, what I brought in. Sorry, I think it's too bright now. It says,
No,
in fact, they're giving you to say, don't know why. Maybe I didn't get this one correct. I think I messed up on this question. Let me see here. Yeah, I think I mixed up this question here because I don't know what it's talking about this one, Yeah, it doesn't show whether y is what, So let's leave that one. Let's come here, and they are saying the equation of a straight line is given as y is minus x minus 3. Then what is the gradient of the graph? So remember, we're saying what? Y is equal to mx plus c. So they want us to find the gradient here. So if I write it here, it will be y is equal to minus x minus 3. They are asking me, what is the gradient? There is the gradient minus, but what is the number there? Minus 1. Because it's a default 1 there. So m is negative 1. Not just negative, but minus 1. And then if they say, write down the constant number. Look at that. And then what's the constant number? There it is, negative 3. That's my C. Right. And then says, complete the table of y is equal to this. I think here you said you don't have a problem of doing this. Am I right?
No, these ones ones I did today. So
yeah, so that is it. And then says, sketch the graph on the table completed this. So even sketching of the graph, I think is standard, is a straight line graph. All right. And then secondly, even this one, they're saying given y is equal to 7 over x, complete the table. I mean, it's simpler, this one. If it's minus 7, there is minus 1. If it's minus 1, it's minus 7. If it's 1, it's 7. If it's 7, it's 1. I think it's also basic there. And then draw the graph on the answer sheet attached. So it's a matter of, I think there was an answer sheet here they gave here.
Oh, yeah.
This one. I think if I remember, minus 7 here, because it was y is equal to 7 over x. Let me just check it there. Yeah, it was 7 over x. So now here I said it's minus 1, minus this is minus 7, 1 is 7, 7 is 1. So they wanted you to sketch it on this, you know. So look at it, they labeled their axis, you see, y,
And
the
X.
x, you see, they did put that, though the arrows are not showing, but it's very important. And then from
Yeah.
there, they gave you some, it's very important now to read the scale here. If you don't, might get penalized. Look at, I'm trying to make it bigger enough. Look at this scale here. You have got the minus 5, 5, whatever. But look, it says each unit. So this is 1, you see that? This is 2, this is 3, this is 4, so that is 5. Yeah. So now if they're saying x is minus 7, so minus 5, minus 6, there is minus 7, and y is what? Minus 1. So there again, here is negative 1, negative 2, negative 3, negative 4, negative 5. So if x is minus 7, there is minus 1. I think it's somewhere even here. There is a point here.
Yeah.
And then minus 1 and minus 7. X is minus 1, which is here. And y is minus 7, which is minus 5, minus 6, minus 7. There it is. You seeing that? And then the other one, x is 1, y is 7. X is 1 and y is 7, 5, there is 6, there is 7, there is a point. And then x is 7, which is here, and then y is 1, and then there is the point. So you see, this is, remember, this is quadrant number 1, and this is quadrant number 3.
Yeah.
We say it when it's positive. Remember, it was a positive.
Yeah.
It's quadrant 1 and 3. And now, you need to know the shape, you know. So it's a hyperbola, so you need to just sketch. You'll say points are not enough. They are enough, my man. You have, a shape that shows this thing was kind of going down, not a straight line, you know.
Yeah.
So in a way, I know I'm not drawing it perfectly well, but this is much better, so, you know.
I see now. Yeah.
So even here, it must kind of curve inside in a bit, like kind of curve inside, passing through there, because I think there was a point there. You know?
Yeah.
But in a way, you have a more stabler hand when you're in a table and everything, you know.
Yeah.
So that is it, Martin. Today, I think we also finished a bit on time. And if I can come back to the previous, my slides here to say the lesson was based on, let me come back here. Because on the graphs, basically that's all. So it was based on this. But if I missed out anything, as I said, you're free to bring in your questions. But this is where we are now, you know.
Yeah.
And then so for tomorrow, and then I'm gonna bring these two concepts here: the geometry, and what you call this trigonometry, so that we can look at it in brief and But mainly trick is gonna be. It's not really much sections. We can do it in 2 days, both of them, and then also we look at conversions on the next day. That's, I think, on day tomorrow is a Friday. I think from Saturday we'll quickly do conversion percentages, but also you'll bring in your questions. To kind of also, it's unfortunate for those guys who have missed actually the most, because actually it's more done. I mean, to me 60% is already done. You know, most of the work is actually on top there. Then but anyway, we'll see as they join us, if ever they are gonna join us. So I don't know if you've got questions at the moment. I'm still free. I still have time with you, but it's up to you. If ever there's anything that you want assistance on.
No, I think currently I'm fine.
I think Thanks. Fine. All right. So we're just laying a foundation. I'm giving you the skeleton. As you say, you get time to revise on your side. But I wish you again all the best as you keep on, putting this all together.
All right, thanks, Comfort. I appreciate it.
Thank you, man. Cheers. Then let's call it a day. Thank you, sir. Cheers,
Okay, bye.